أهلا أستاذ.
هلا كريس، كيفك؟
بود أنت كيفك؟
جود.
أستاذ؟
يس.
هلا شوف أنا جاي بدي أعمل كمبيوتر انجينيرنج. أوكي.
يس.
هونيك شو أنا أهم كتير شيء بتعرف أنت.
First year you have to take math.
يس هيدا عادي.
بعدين حسب
هيدا كله هاو.
no integral calculus يعني integrals probability sequence.
استاذ هلا امبارح هذا السير كان بقى عم ياخد هيك شيء. قال بان انه هيدا انت تبع السيكونس. هيدا عم بياخد هلا.
ايه رح بياخذ السيكونس.
يعني في فيرست انا هو بياخد.
يس first year.
بعدين عادي.
يس بعدين قديش تاخذ مات؟ هلا اذا كانت your grade good بالاوفيشال exam instead of doing calculus 2 you start with calculus 3.
هيدا اصعب. الكالكولستري اصعب من تو.
يس.
ايوه.
هلا
استاذ اذا كان اعطوان افاده
تعمل exam entrance exam حسب according to your grade.
اوكي.
So be good. بتوفر عليك اول شيء سيمستر، وبعدين بتوفر عليك مصاري.
يس.
only حتى الانجليش كمان the same. Where is Haikaz? Send a message for Haikaz خليه.
استاذ هلا قال وان من تال افتح واتساب عندك كمان في كاتب استاذ 1 minute.
Okay, we'll wait for a few seconds. Which university you are going to study?
أنا؟
Yes.
استاذ I don't know yet. بصراحة استاذ مضيع.
LIU ولا ولا غير ولا
اللون برو ما غير ايوه بيو ايوه. هيدول غالي كتير.
AUST.
لما بشوف اي واحد احسن بالبان كمبيوتر انجينيرينج بروح هونيك.
اوكي. توماس شو بدك تعمل أنت؟ توماس your internet is very weak.
توماس
ايه الو
Ura Islan.
واي فاي is the garage shot from درهم
أنا الواي فاي.
هذا ولد وغاطا يقصد
مش كده؟
استاذ
Okay, let's going to start. Haikaz is not going to join. Exercise 7. Consider the sequence un defined by u0 equals 3 over 2. And un plus 1 equal 2 plus u squared n over 2 un. Part 1. How to show the sequence un is bounded below by radical 2. How to show the sequence is bounded below by radical 2. What we do in order to show this?
نعمل UN minus radical 2.
What will be un minus radical 2 if we make un minus radical 2? Equals 2 plus u squared n over 2un minus radical 2.
بشوف استاذ هيدا هو هون UN
Plus 1.
لا plus 1.
Yes, so by induction. Okay?
اوكي.
We are going to prove by mathematical induction. كيف mathematical induction? First, u0, how much is u0?
3 over 2.
3 over 2. 3 over 2, compare 3 over 2 with radical 2. So, exercise 7, we are going to verify that un is greater than radical 2. u0 equals 3 over 2. 3 over 2 is 1.5. Radical 2 is 1.4. So u0 is greater than radical 2. By induction, okay? By induction. So u0 equals 3 over 2 greater than radical 2. First step is true. Suppose un greater than radical 2. Show that un plus 1 greater than radical 2. First step, second step, third step. We are going to show that un plus 1 greater than radical 2. Now, un plus 1 minus radical 2. un plus 1 minus
هذا 2 او راديكال 2
شو؟
هيدا UN greater than 2.
greater than radical 2. Suppose UN greater than radical 2. Show that UN plus 1 greater than radical 2. So UN plus 1 minus radical 2 is 2 plus U squared N over 2 UN minus radical 2. We take LCM بصير 2 plus U squared N minus 2 radical 2 UN over 2 UN. The numerator is an identity. I can write it as UN minus radical 2 squared over 2 UN. هيدا identity A squared plus B squared minus 2AB is A minus B squared. هيدا positive. هيدا square is always positive. Will UN is positive because we have we suppose that UN greater than radical 2. So UN plus 1 minus radical 2 is positive. So UN plus 1 greater than radical 2. So UN is bounded. So UN is bounded below by radical 2. Radical 2, this one. Any questions شباب أول part?
No.
Did you finish writing?
Yes.
Yes. So here radical 2 is a lower bound. Prove that the sequence is, how to prove that the sequence is decreasing?
نعمل UN plus 1 minus UN.
Okay. UN plus 1 minus UN. UN plus 1 is 2 plus U squared N over 2 UN. This is UN plus 1, it is given, minus UN. LCM, we get 2 plus U squared N minus 2U squared N over 2 UN. Now, how to study its sign? UN is positive. What about the sign of 2 minus U squared N? We have UN. UN is greater than radical 2. In U squared N أكبر من 2. Then multiplying by minus the two multiplying by minus, this is minus U squared N less than minus 2. Then 2 minus U squared N is negative. So UN plus 1 minus UN, this one is negative. Over positive. It is negative, so UN is a decreasing sequence.
استاذ
Yes, Chris.
هلا هيدا هون كيف عرفنا انه فوق is negative وتحت is positive.
if من part for un is greater than radical 2, un is
Yes.
greater. So un is positive, هذا positive. To know the sign of 2 minus u squared n, I have un greater than radical 2 من previous part. Squaring the two sides, I can say u squared n greater than 2. If I take u to that side, u squared n minus 2 negative, minus 2 positive.
Yes.
Multiplying by minus, so 2 minus u squared n is negative.
Yes.
Last part, find the limit of this sequence. How to find the limit of this sequence? How to determine the limit?
نعمل أقل من حتون.
Yes, بس قبل ليش ما نقول عندنا limit? Why it is why it admits a limit?
لأنه bounded and decreasing.
Bounded and decreasing, it contains a limit. بنحط محل ال un وال un plus 1l and we determine the limit. So here un is decreasing, un is bounded from below by radical 2, then un is convergent. Then the limit as n tends to plus infinity of un plus 1 equals, here should be limit on this side, limit as n tends to plus infinity. So L equals 2 plus L squared over 2L, cross multiplication, 2L squared equal 2 plus L squared, then L squared equal 2, so L equal plus or minus radical 2, but since un is positive, this one is rejected.
أستاذ أستاذ
Yes,
هلا بالآن التست أمان هيك
بكره وقت نشوف
بيجي
السيشن.
من الصغير.
Yes, بكره نشوف بالسيشن كيف بيجوا. Okay, is this one done?
Yes.
Problem 8. Let f be a function defined for x greater than half by fx equals x squared over 2x minus 1. Domain who we have plus infinity. Consider or define the sequence by u0 equal to and un plus 1 equal f of un equal u squared n over 2un minus 1 for all natural numbers. They are the same, but we replace x by un. One part A. How to prove that for x greater than 1, fx greater than 1? How to prove fx greater than 1?
أعمل derivative.
طب إذا عملنا derivative وطلع negative أو positive, how to prove fx greater than 1?
بنشوف ال x greater than 1 over 2.
The easiest.
ما نشوف هذا البان ماكس هم على التيبل.
اوكي بس نجيب الليميتس على الانفينيتي وعلى الماينس انفينيتي على الانفينيتي. نشوف المينيموم والماكسيموم بس في easier than that. What is easier than that? What we do?
ناخد un greater than 1 over 2.
We need to prove fx, not u. Fx greater than 1.
بنقول إنه x greater than 1 over 2.
So I take the difference fx minus 1. What should be the difference fx minus 1?
Positive.
Positive. So fx minus 1 is 1 part A is x squared over 2x minus 1 minus 1. The LCM is 2x minus 1. X squared minus 2x plus 1. This is an identity a squared minus 2ab plus b squared. It will be x minus 1 squared over 2x minus 1. This one is positive, x minus 1 squared is positive. And since x greater than 1, 2x minus 1 is positive. X greater than 1, 2x minus 1 is positive, so it will be positive. So fx greater than 1 for every x greater than 1. Any questions, Chris?
No, Ustaz.
Part 2. How to deduce that un greater than 1 for all natural numbers? How to prove un greater than 1? Now I need to deduce, okay?
نعمل un plus 1 عنا إنه fun equal.
So I use mathematical induction.
Yes.
How much is u0?
2.
2.
2. And u0 is greater than 1. u0 is greater than 1. Suppose that un greater than 1 required to show un plus 1 greater than 1. So by induction, u0 equal to greater than 1. Suppose un greater than 1. Show that un plus 1 greater than 1. هلا since قلنا هو deduce نحن معنا بالprevious part انه for each x fx greater than 1. So since un is greater than 1 يعني f of un is greater than 1. F of un is un plus 1 greater than 1. since un greater than 1, I have to prove un plus 1 greater than 1. Since un greater than 1, then f of un greater than 1. Since fx greater than 1, so f of un greater than 1 implies un plus 1 greater than 1. Part 2. Consider the two sequences Vn and Wn. Vn and Wn such that Vn equal -1 plus Un over Un, with Wn equal ln Vn. Wn less equal ln Vn. How to verify that Vn and Wn are defined for all natural numbers? How to verify Vn and Wn are defined for all natural numbers?
For all natural numbers يعني positive.
Yes.
عندنا Wn is ln Vn. يعني Vn is positive.
Yes.
يعني Wn positive.
هلا Vn why it is defined for all natural numbers؟ لأنه we have proved that Un is greater than 1 مش هيك؟ Yes ولا no؟
Yes.
Yes.
So Un is different from 0, so this one is defined for all natural numbers n. هلا ln Vn, what is the inside of ln should be what?
Positive.
Positive. Why Vn is positive?
قلنا
Yes, what did you say?
since Un greater than 1.
Yes. So since Un greater than 1, since Un greater than 1, Vn is defined for every natural number. Wn equal ln Vn. Wn equal ln Vn equal ln -1 plus Un على Un. Since Un greater than 1, then Un -1 positive. So هذا positive صار. هذا صار positive. So Wn is defined for every n. Part B, how to prove that Wn is a geometric sequence whose common ratio are equal to. How to verify a sequence is geometric? Yesterday we took an exercise. To prove geometric sequence, you have to prove that Wn plus 1 over Wn equal R. Wn plus 1 over Wn equal a constant number R, that is 2 in this exercise. So we have Wn equals Wn equals ln Vn equals ln minus 1 plus Un over Un. Wn plus 1 equal ln Vn plus 1 equal ln minus 1 plus Un plus 1 over Un plus 1. We replace Un plus 1 by its value. بيصير minus 1 plus 2u squared n over 2un minus 1 over u squared n over 2un minus 1. So I find Wn, then Wn plus 1. LCM. Did you finish writing till here?
استاذ
Yes.
هيدا هون اللي يو ان كيف صار يو ان بلس 1
Wn plus 1 هو ln
Yes.
Vn plus 1.
اوكي يس صار.
Can I go to the next slide? Did you finish writing?
Yes.
So it will be ln minus 2un plus minus 2un plus 1 هي 2un لحالها plus 1 alone plus u squared n. I can write it. This is an identity. Un minus 1 squared over u squared n.
استاذ شو عملنا؟
I take the LCM here. خدت ال LCM صار ln two un minus 1 فوق بصير عندنا minus 2un plus 1 plus u squared n over u squared n over 2un minus 1.
استاذ هيدا الماينس 1 للان او لحاله؟
Yeah.
هيدا ماينس
هاي لحاله هاي لحاله. هيدا وهيدا بيضل في عندنا u squared n minus 2un plus 1. It is an identity. هيدا إذا بدنا في step هون فينا نحط ln square. هيدا square بينزل بصير 2 ln un minus 1 over un. So wn plus 1 over wn will gives 2. هيدا 2 ln un minus 1 over un over ln un minus 1 هيدا وهيدا بيضل في عندنا 2. So wn is a geometric sequence of common ratio r equal to
استاذ يعني بالاول جبنا يو ام بلس 1
جبنا wn plus 1 جبنا WN
W
WN هو لام VN لقيت الفاليو تبعه رجعت جبت WN plus 1 هو لام VN plus 1 we replace Vn plus 1 by its value بصير minus 1 plus Un plus 1 over Un plus 1 after that do I divide Wn plus 1 by Wn لازم يطلع constant number and in this example it should be 2
okay.
now to calculate the first term equal W0 equal ln V0 W0 equal ln V0 equal ln V0 is minus 1 plus U0 over U0 لأنه Vn هي minus 1 plus Un over Un ln V0 equal minus 1 plus U0 over U0 U0 is 2 it will become ln 2 minus 1 over 2 it will be ln half هي ln 1 minus ln 2 it is minus ln 2
ليش عملنا first term؟
always لازم نلاقي first term بس هي هو قايل لك calculate the first term always مع geometric or arithmetic we have to find the first term and whose first term is to be determined first term is W0 have you finished writing
أستاذ هيدا هون شو صار الفيرست ترم؟
first term هو اسمه sequence WN هذا WN the first term is W0 equal ln V0 V0 بلاقيه من هون V0 equal minus 1 plus U0 over U0 بصير minus 1 plus 2 over 2 بتصير half ln half
Okay. Yes.
express Wn and Vn in terms of n express Wn and Vn in terms of n since Wn is a geometric sequence since Wn is a geometric sequence, we have a rule Wn equal V0 times R power n. Equal, not V0, equal W high. This one W0 times R power n. W0 is minus ln 2 times 2 to the power n. Now, in this way, I calculated Wn. Now, it is required to calculate Vn. Wn equal ln Vn. If I need to calculate Vn, I have ln here. To remove ln, I add e. So Vn equal e to the Wn. Vn equal e to the Wn. E to the Wn equal e to the minus ln 2 times 2 to the power n. This is the calculation of Vn. The last part, deduce the expression of Un, then calculate the limit. Deduce the expression. So Vn equal minus 1 plus Un over Un. Cross multiplying. I need to calculate Un. So Un Vn equal 1 plus minus 1 plus Un. I have to calculate Un, جيب UN to this side. Un into Vn minus 1, أخذت Un common equal minus 1 So un equal -1 over Vn minus 1. I replace Vn by its value. يصير -1 over e to the minus ln 2 times 2 to the power n minus 1. Now finally limit as n tends to plus infinity of un. هلا 2 to the n is infinity plus infinity times minus ln 2 بصير minus infinity. Limit 2 to the n is infinity times minus ln 2 بصير minus infinity. E to the minus infinity is 0 and the limit is equal to 1. The limit is equal to 1. This is all for today. We'll continue tomorrow.
Okay. Cheers.
Okay, yalla. Did you finish writing?
Yes.
Yeah.
يلا نشوفكم باي باي.